I want to just kind of start by saying that like a blockchain developer is really just a developer who has studied some specific skills. So yeah, if this is something that like you think you could do or you are interested in, like there is definitely a pathway there. And I am not, I'll just say it, I'm not good at cryptography. I'm not just
Okay.
a lot of those really low level, like I'm not good at game theory. I'm not good at those things. I know it's scary. I just said I do consulting, not that kind, don't worry. But like, but I am very good at building integrations, right? And so as it turns out, and we'll talk about it, like there is actually a huge opportunity in the blockchain space for integrations and like apps that integrate with blockchain applications. That also requires some of that knowledge and is a great way to develop your skill. But yeah, like you don't have to be in there like contributing to blockchain core if that's not something that you think you would enjoy or be good at. So there's lots of ways to do it. Anyway. It's not that complicated. Blockchain is just a database that is really good at replicating data across trust boundaries. So if you've got like a consortium of companies or a disparate group of individuals or like even the general public, and they all want to agree on a set of facts, the outcome of the program, like the state of the universe, if you will, but they don't trust a central authority or coordinator to keep track for them, right? This is where blockchain really shines, right? And it is optimized for this use case, kind of at the expense of everything else. So there are some use cases, and I'll talk about some of them throughout this, where blockchain is the solution. But most of the time, it's either just part of the solution, or actually most of the time, you'd probably just be better off with a regular database. And actually, one of the biggest problems we have in the industry is that blockchain and especially tokens gets like wedged into solutions where they don't really belong. But let's not get into that because we'll be here all day.
Okay.
So basically what I'm trying to say is like there are actually two types of blockchain app, and as I'll explain, there's even three types of blockchain developer. But so for blockchain apps, there are smart contracts that like live on the blockchain. But a substantial portion of blockchain apps are actually just integrations, like traditional apps where a blockchain node is just part of the stack. So first type, we'll go like lowest level to highest level. So lowest level is the protocol layer. So layer one, layer two solutions, as they're called. This is where you're like literally building your own blockchain or consensus protocol, right? So this is like the actual blockchain, like you're contributing to Bitcoin source code or the Ethereum source code, the Monero source code, right? And I guess also I should say like so blockchains are, they are at a very theoretical level, they're like a communication protocol. They're a set of rules that all the participants in the network decide to agree upon in order to arrive at consensus, right? They take the form, sort of physically, if you will, of like a node. So it is like a server that is connected to a network and it's exchanging messages with other nodes in the network. And through collecting these messages and comparing them, the node is able to arrive at a consistent view of the state of the blockchain, right? So you'll be working on either a communication protocol or you'll be literally building the app that is running a server to connect to the network, right? So that's like your layer one. There is also layer two, which is like a secondary network that links to a blockchain and it provides better throughput or sometimes different functionality, usually at the cost of being more centralized. So an example of layer two protocol would be like the Lightning Network, Polygon, Starkware, things like that. I'll talk about like the skills you would actually need to contribute to them in a sec, but I'll keep going and I'll talk about the other two types of blockchain dev, and then we'll get into the skills. So the second type of blockchain dev, a little bit higher level, is like the smart contract developers. So these are people who are building decentralized applications that live on the blockchain. So smart contracts on Ethereum, Cardano, Substrate, and so on. And then the third type of blockchain developer, and the most common one, is developers building integrations. So applications, libraries that integrate traditional apps with smart contracts. So these are like Web3, the Piota library that I talked about, and so on. Because the funny thing about smart contracts is like, so technically you can interact with a smart contract directly. So you would craft a transaction and then you would broadcast it to like the Ethereum blockchain. to the network, and then that would be a way of communicating with a smart contract. But generally, users are usually meant to use like a bespoke web application or like a front end to interact with them instead. So as an example, there's a DeFi app, it's called Enzyme. It has very sophisticated smart contracts that are deployed to the Ethereum mainnet. And if you know what you're doing, you can interact with it directly by crafting and broadcasting Ethereum transactions. But most users will use the Enzyme.finance web app, which uses Web3 under the hood to send transactions to the smart contract. And the reason we do that, one, it's just a much better user experience. But two, the web app also allows the developers to implement business logic and validations and some other checks that would be difficult or impractical to code directly into the smart contract. As it turns out, like smart contracts are like a different programming paradigm. I'll talk about it in a bit, but we'll get there. I think that's been most of what I've said in this in this call so far. Just trust me, we're getting to the good stuff. We're getting there. Bear with me.
No worries. I trust you.
So anyway, so yeah, so just like how like blockchain nodes are just part of the stack for many applications, it's kind of the same thing that smart contracts are just kind of part of the stack for a lot of web applications. So one theme that you're probably hearing a lot of here is that like being a blockchain developer is kind of like being a web app developer plus blockchain. That is a viable route, and I think a lot of developers, that's the route they take to get into this field. Yeah, what do you actually need to learn? Okay, so let's start with the first, like the protocol level. Honestly, this is way above my pay grade. I already said I'm not good at cryptography. I'm not good at like algorithms and designing messaging protocols. I can port it from JavaScript just fine. Don't worry, Pyota's fine. But like getting in there and doing the maths, getting in there and getting into like the science of it, that's not an area I can really talk about. So I'm going to acknowledge that exists, but I can talk about this in kind of in general terms. So just first off, if you are New Zealand based, there are a couple of organizations that are building their own consensus protocols, their own blockchains. Secure Scuttlebutt is a well-used one. There's also SensNet that's in development here. And from a language, like a programming language perspective, there's lots of options. So like Bitcoin Core is written in C++. Ethereum nodes are Golang, and there's also JavaScript implementations that I've worked with in the past. Substrate is written in Rust. IOTA nodes used to be Java, now they run on Golang. Corda runs on Kotlin, and so on and so on. Like so, there's very few languages that like don't have some kind of a blockchain implementation that's been written in it, and those are just the official implementations too. So there's also ports and alternative implementations and such. So basically, no matter which programming language you're comfortable with or you're used to or that you want to work in, there's a good chance that there is some technology out there that is already written in that language. So you don't necessarily have to learn a whole new programming language if you want to work on like the consensus layer of a blockchain protocol. And the other cool part about it is that for at least for permissionless ledgers, they're all open source by definition. Like the network can literally only function if everybody can download, compile, and run the code, right? Anyone needs to be able to run a node, or else you don't actually have a permissionless ledger. So if you do want to hack on a layer 1 or a layer 2, getting started is honestly the same process as for any other open source project. Like find one that you're interested in, download, compile the source code, get a feel for it, check the issues on the repo for anything that's tagged help wanted or good first issue, and give it a shot. So that would be like protocol level. If we go up a level and we talk about smart contracts. So as of today, Ethereum's EVM is still like the most popular engine for smart contracts. So I would say if you do want to build smart contracts and like you don't have a strong preference for a specific protocol like Cardano or Substrate, then like market forces, if you will, would dictate that your best bet is to learn a language like Solidity. If you prefer something more Pythonic, Viper is a good option, but I'd say Solidity is way more widely used. And you'll want to familiarize yourself with smart contract development frameworks like Truffle or Brownie. So those are really good. They will allow you to develop and test your smart contracts locally before you deploy them to the blockchain. And then also, if you are working with Solidity and you are comfortable with DevOps, do make sure you integrate Slither into your build pipeline. That's a static code analysis tool. It will help you catch security issues with your contracts before they go out into the wild. I'm sure if you've been studying blockchain for any length of time, you've heard about some of the dramatic hacks and exploits and millions of dollars worth of tokens being stolen. Don't let that happen to you. Make sure you audit your smart contracts before they go out into the wild. Upgrading smart contracts, like deploying new versions of your software, is actually really hard to do on a public blockchain. It's one of those things that we take for granted in regular applications, but on the blockchain, it's a lot harder to do. There are solutions and there's techniques for doing it, but it's one of those things, if you don't think about it, it will bite you. So and there's some great guides out there for getting started. Crypto Zombies is probably my favorite. So if anybody remembers CryptoKitties, it's like the original NFT game. Crypto Zombies is literally learn how to build a smart contract by building a zombie themed version of the CryptoKitties NFT concept. It's quite fun. Also, Open Zeppelin's Ethernaut is really good. It's kind of based on Over the Wire's War Games, which is a great tool for just learning sort of network hacking, the good kind of hacking, not cracking. So that's also a really good one. It's almost learn how smart contracts work by trying to hack the protocol. So very, very good resources. Yeah. The biggest challenge, as I mentioned, to overcome is that you're not designing applications, you're really designing communication protocols. I guess some would argue that's what object-oriented programming actually is, but never mind. It's a different paradigm. So things are going to work a little bit differently in smart contracts than you may be used to from working on web applications. So simple example, every computational operation that a smart contract performs costs money. So a construct like an unbounded loop is actually an anti-pattern in a smart contract, right? Also, as I mentioned, upgrading smart contracts that are already deployed, it ranges from tricky to flat out impossible, depending on how you've designed it. So this is a case where a lot of thought has to go into how you actually architect and design your smart contracts, even before you think about the business logic, right? Now, the good news is you don't have to do this from scratch. There's lots of frameworks out there. Open Zeppelin has lots of patterns for how to do this effectively. But it's just really key to be aware that there are going to be a lot of things that you might be used to taking for granted when building traditional web apps that are just going to work differently, or in some cases not at all, when you're working on smart contracts. So just like entering any kind of new, when you're playing in a new playground, you just have to make sure you're doing lots of research, keeping up to date on best practices. Make sure you're not rolling your own. So familiarize yourself with libraries like Open Zeppelin. Make sure that you're sort of using those patterns as a base. Number 3, integrations. And personally, this is my favorite category because it's the one I play in the most, and it's the most diverse too. I would say there's 3 different types of blockchain integrations because I'm a developer. I like putting things into boxes. And so the first type is SDKs and libraries for interacting with blockchain nodes, right? So as I mentioned, a blockchain network is just a whole bunch of these servers that are just running and they're exchanging messages with each other. And so if you want to interact with the blockchain, you just send messages to these nodes, either transactions that you want to broadcast or queries give me all the transactions for block number 1234. And so what's cool about these is honestly, for the most part, they're just HTTP API client libraries, and they just have a few extra features for key management, signature generation, things like that. So Pyota, it's a library to allow Python applications to interact with IOTA nodes so that they can look up and broadcast transactions on the Tangle. But at its core, it's honestly just an HTTP API client library written in Python. And yeah, it's got some extra features for key management and signature generation, and also some bits and bobs for translating between binary and balanced ternary, but that's an IOTA thing. It's a cool thing. I definitely recommend you check it out. Balanced ternary is way better than binary in a lot of ways, but that's specific to IOTA. Anyway, but at its core, it's an HTTP client. And fun part about SDKs and libraries is, yeah, they tend to be open source as well. So just like contributing to layer 1, layer 2 projects, the approach is the same. Find one that interests you, look for issues you can work on, and submit your first pull request. So that's the first type. Second type, usually backend applications that query blocks or transactions on the blockchain and or emit transactions as part of their business logic, part of their operations. Simple example. If you go to notary.bitcoin.com, it will store a hash of a document on the Bitcoin blockchain. so that you can prove that you had a document with a given hash at a given point in time. Very, very simple. It's an application where interacting with the blockchain is part of its operation. And then the third type is usually front-end applications that use Web3 or a similar technology that allows users to interact with smart contracts from their web browser. So I mentioned Enzyme.finance before as a good example of that. And there's lots and lots and lots of other examples. You'll know you're using a Web3 powered application because there won't be like a username password login. Instead, you authenticate using a blockchain wallet plugin like MetaMask or Wallet Connect. Layer 1 or layer 2, sorry, I can't help you. However, if this is something that is of interest to you, it's just like contributing to any other popular open source project. Learn as much as you can about it, hang out in the discussion boards, target low-hanging fruit, like documentation or fixing typos for your first contributions. My first ever pull request to an open source library was like adding a couple of lines to a git ignore that had been left out. That's it. That was my first ever pull request. And there's lots of opportunities. If as you're going through and you're going through the documentation, you see a typo or something's a bit confusing and you think once you've kind of figured out what they're trying to say, you're like, there's probably a better way that could be like worded or explained. Like hop on the repo and just submit a quick pull request. It's just a great way to get used to it and to get started. And just look for like low-hanging fruit. A lot of projects, they will tag issues as like good first issue or help wanted. These are not things where you have to like know the whole code base inside and out. They're great issues for someone who just has a passing familiarity and wants to just get a little bit deeper with their knowledge of the framework. So I would say, like, as much as I really do apologize, I couldn't tell you like learn these things or study these, these things or take this course. But what I can say is that like the approach is going to be very similar to a lot of projects you may have already seen. For smart contracts, I would say unless you are targeting a specific blockchain, learn Solidity and its ecosystem of tools, techniques, and libraries. And then lastly, apps and integrations. So getting familiar with Web3 is a really good starting point because that's going to teach you the concepts that you'll need to understand in order to build apps that interact with smart contracts. Even if you are going to work with mostly back-end applications, just learning how a Web3 application works and how you're not authenticating to a server, you're actually putting control in the user's hands and you're interacting by broadcasting transactions to a blockchain. And so how that's different from like a traditional API request, I think is going to be a great stepping stone to teach you the concepts. And then from there, a lot of these are largely the same as integrating any other HTTP API into your applications. I think you'll feel right at home very, very quickly.